Hopefully everybody can hear me. I wonder if Think of Hours are watching together. Well, that was weird. Eric, are you and Mark watching together? Just let me know in a comment or say yes. Just so, because technically I'm supposed to take attendance, and I'll kind of put a like just in case, even though, oh no, Eric and Mark are watching separately. What do we have here? 16. I think that's more than the grade 9 or grade 10s all put together. I'm going to record these just in case. I think I may change that back to just letting you guys go in. What did I say in here? Try to be like half an hour. I'll save it in case you miss it. I'm going to go, come on, you piece of garbage. Foundations, then the answers to all of the questions. I think this is the, yeah. So that file that's there from earlier, all of the counting methods stuff, we're now on chapter number 4, somewhere down here. Oh, okay, further. There. So all of that sort of stuff, all of those notes, the page that we were on or should be on, are in there. I can't remember where I stashed those answers, but I don't know if that was dumb. Okay, the textbook answers are right there. So you can go use those to check there. If you need to contact me, you can use the chat thing. I don't know who this guy is who messaged me earlier or tried to call me, I guess. I'll record and post stuff. My goal is to keep this to like half an hour, because if you're doing this for 5 classes, sitting in front of a screen for 5 hours a day would be brutal. I mean, let alone listening to a teacher who's, I don't know where we're going. We're at 16. Grace, Paige, Mackenzie, Jason. I don't see Fournier. I don't see Shane. Trying to just think about where people sit in class based on. Oh, right. Yeah, nope. Dominic Hayes. Is Dominic Hayes there, please? Oh, okay. All right. So let's go on to some spectacular fun stuff. On Thursday, seems like such a long time ago, we did all of these things that was just ways to count things. There are 17 million possible license plates in the world. New Brunswick has limitations. New Brunswick starts with, gosh, what did both of, my old one used to be G. I think most license plates start like there's the first letter has less. We talked about the deck of cards. Whether I give you that picture, I really need that poster. And that was the homework. We talked about answers. You can email questions. You can do that at the end. I'll probably stick around a little bit later because you guys tend to ask more questions in the grade 10s. So that was our homework. One poopy thing about the way I did this is like, hey, that's something that in class I would let you write down. I'll give you a second to write it down. You'll be able to do it. Again, permutations are arrangements of distinguishable objects that have a definite order. Everyone can hear me, right? So distinguishable. I said an example in class the other day that if we put all of you in a lineup, well, other than, well, even Eric and Mark being twins are still distinguishable because they have different haircuts, they have different names, and all of that. So they're not the same, even though we're going to use that as an example and when we get into other things, and a definite order. So if I lined you up and, oh, the order in which you went to the bathroom, the order matters. If you really have to pee and you're first in line, you're set. But if you're 16th in line, you're in trouble. And this is going to be kind of the mantra, or the thing we have to ask ourselves for most of the rest of this unit. Does order matter? If we have two things, object A and object B, there's two permutations. A first, B second, and B first and A second. And there's different scenarios and all of these things. Oh, hey, this is, I said this morning, it's like the hardest part about doing this is even though I'm recording it, and some of you will go back and watch it and all of that, when I put the link, I can't see who's writing and who's not and who's finished and who's not. So we're probably not going to get through everything today. I'm not gonna rush it. I mean, I've got 3 things of notes. Whoa. But we'll go through a little bit and we'll figure out where we stop. If there's homework today, there's homework. If not, so be it. But that's the way this week is going to be. However long it is, there's a press conference at 2:30, and we'll see what old Blaine has to say today. Can I go down? And I'll post all of these completed. Determine the number of arrangements that 4 children can form when lining up to go to the bathroom. Does order matter? If all 4 kids have to pee and the teacher is a jackass like me and says one at a time, does order matter? Yes, because the first person gets to go to the bathroom first, then the second person, the third person, the fourth person has to sit and wait and hold it. So we're going to kind of do this in the same idea as these, but it's about choices. Permutations is about choices. How many possible kids can go in that first spot? Well, there's 4 kids. It can be any one of those 4 children. The first person goes. How many children are left for the next spot? 3. The next person goes. There's 2 people left. And then there's that poor soul at the end. And this is child 1 goes, and child 2, and child 3, and child 4, because these are all choices. CHOI. We're going to multiply all those together. 4 times 3 is 12. 12 times 2 is 24. Times 1 is 24. So there's 24 different ways to put 4 things in order, whether it be 4 books, 4 chocolate bars that you're going to eat from last night if you went out trick-or-treating or you just stole whatever your siblings had or whatnot. If you put 4 things in order, there's 24 different ways to do that. So far, so good. This is where I need like thumbs up. Everybody happy? Apparently, hopefully yours has this in here. Stupid McKay had the same question twice. But now we've changed 6 songs on your this you don't really need to copy down. Oh, what is it? Apple Music? Oh, what's this? People are waiting. Oh. Hi, Joey. I'm recording this, so the however many minutes you've missed, you can catch up on. We just did one example, which this one's a little more complicated, and then there's that definition at the top. Determine the ways 6 songs in a playlist can be played. Well, we're going to play 6 songs. We're going to assume there is no repeats, because if there's repeats, it gets a little bit more complicated, but we can do it first with no repeats. How many choices are there for the first song? Well, there's 6 songs in the playlist, so there's 6. We've played 1, there is 5 left. We've played 2 now. If I knew how to use the pen, there is 4 left. 3, 2, 1. Is this Shane? Be right. Oh, Eric. What? Eric got booted. Yeah. Hopefully everyone's internet is somewhat stable enough. I understand that if you pop in and out or you miss some of these or whatever, everything will be there. We'll talk about it whenever we're back together. 30, 4 threes is 120, 360 times 2 is, so if you have a 6-song playlist there and you're shuffling and they can only play once, there's 720 possible combinations. Now, with repeats, this gets a little bit, well, not really more complicated. With repeats, well, there's 6 songs. If I can play that song again, there's 6 songs. If I can play the songs again, this is one of these ones where it's like, that's 6 to the 6th. I do not know what that number is. Whoa, that would be bad. 46,656. Or 6. I will give you some clarification on something like this. Oh, do they go, can you repeat or can you not? I have to give you that kind of thing. So far, so good. Everybody happy thus far? It's so weird. Talking to quiet. So I'll give you a second to try to figure out how many ways 5 different books can be arranged on a shelf. 1, 2. I just need to double check that I'm not going to ask a question that's going to be here in a second. So, hopefully that's enough time. Well, how many books are there? 5 can go in the first slot. 4 can go in the second. 3, 2, 1. Oh, wait. 6, 2, that's 120. Okay, slightly different. I either hear my wife watching videos downstairs, which is not likely because she's working, or there's kids outside yelling and screaming. Whoa. What happens if we add a restriction? What happens if Mr. McKay is organizing this and he's a nerd, like, and puts the chemistry book first? Do we still have 5 spots? I really should just keep using these instead of freehanding these lines. What happens in this case? Well, how many choices are there in that first spot if this chemistry book must go first? 1. So the chemistry book is in that first spot. Then we have 4 more spaces. Well, there's 4 other books to go here. Really? There's not, but we can't add, like, I can tell you what order I would put the books in, but that's totally irrelevant for the question. There's 4 books that could go in the second spot. There's 3 books left that can go in the third space. 2 and 1. Because Mr. McKay's a nerd, he takes that from 120 down to 24 ways to organize those books. So when you have limitations, I'm just going to give you a sec to finish writing that down. Then I think there's a question down on the bottom that's similar to this, or a license plate question if the first letter has to be G, J. I don't know if we have H's. I know my old car's license plate was GZG, which I thought was kind of cool because it sounded cooler than I am, like a hip hop thing, GZG. But you can all laugh. It's okay. I am a loser. There was one question I saw down here. Baseball coaches determine the order for 9 players. 9 players he is fielding. He wants to do a batting order, but the pitcher has to go last. How many choices are there to go last? And some of these we're not going to actually calculate because they're ridiculous. But if you've noticed, we have these 6 times 5 times 4 times 3 times 2 times 1. And 4 times 3 times 2 times 1. And 5 times 4 times 3 times 2 times 1. And then that one is a little bit different. There's a notation in math called factorials. We're going to do some of this. I'm going to see what's in the back here. In an expression n factorial, this is the button I said on your calculator you had to have. Of course, they've changed this. You piece of junk. Seriously? This makes me so mad. Oh, never mind. I guess it doesn't make me that mad. We had, our first question was 4. Factorial is 24. 5 factorial is all of that. So we can do all of this. Factorial notation. N is defined as a part of the whole numbers. N is contained in 0, 1, 2, 3, 4, 5, 6, yada, yada, yada. 0 factorial is defined as 1. Logically, how many ways are there to arrange nothing? 1. So I'm going to fill this in. 1 factorial is just 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 1. Sorry, my time signs are a little off. Back to red. 10. And we could keep going on this. All you do is you just add stuff. This is probably where I'm going to stop. I'll pick some questions we'll talk, from the homework. I'll talk about what we're going to look at tomorrow. But these things grow. 6 factorial is 720. 7 factorial is 7 times that. 7 sevens are 49. So this is like 5,000. 8 factorial is going to be somewhere on the order of 40,000. 4 nines are 36, so 360,000. 10 factorial is 3 million. The letters in the, oh wait, there's 18 of you who regularly go to class. So if I were to put you in a line, there's 728, 705 million, 6.4 trillion ways to arrange you in a lineup, because there's 18 of you who are regularly in class. I don't know if everyone's there today. 17. Poor Shane. Shane's missing out on all the fun. So we can do this in terms of variables, and we'll do a little bit. N factorial is n, whatever that is, times. Well, what's 1 less than n? N minus 1. What's 1 less than n minus 1? N minus 2. What's 1 less than that? Now, this is one where it's a hypothetical thing. I don't know, times however many things n is, times 3, times 2, times 1. N plus 1 factorial, well, n plus 1. What's less than n plus 1? Well, n. And we just keep subtracting. But they all technically end in 3 times 2 times 1. So far, so good. Hopefully nobody screenshots those funny faces. I trust most of you. It's the quiet ones I worry about. So tomorrow we'll look at some of this stuff with factorials. I need to go back down through here. So that's all factorial stuff. Well, I forget. What questions do I have down here? So let's start with 2. Seven, 8, 9, 10. Oh, just a sec. No, that's a whole different section. Okay. Just didn't want to. Sometimes I use the same things. So 2, 7, 8, 9, 10, 12. And we'll deal with the other stuff later. 2. Some of these are going to take literally seconds. There's one of those that I think if it's 28, don't list all of them. Just say 28 factorial. I think I said 10 and 12. And we'll deal with those other questions tomorrow. What do I need to export? 2-page. So what I'm going to do for those of you who think, God, this bonehead's going way too fast. 1 to 11 as a PDF. See where this is going to point me, not grade 10. I'll just update this as we go. So that's where I wanted to get to today. I don't want to take more of your time. It's 25 after 1. Apparently, I've been here for 27 minutes, but that's a good spot to stop. Tomorrow we'll finish that one, and we'll go from there. Are there any questions? Check the answers, but if you have no questions, you're free to go and wait until your next class. Take a break, have a nap. I told everybody else to get outside because it's like, according to my thing over there, it's just like 13 degrees. It's going to get colder, so go outside, take some fresh air and all of that. But if you're good, we will see you all tomorrow at the same time. And have a good afternoon. I'll wait until most people are leaving. Inevitably, someone will be here for like 2 minutes after everyone else has left, and it's like, yeah, they fell asleep. Adios. See you later. Oh.